Hello everyone, Namaste. Welcome to our presentation here. I'm going to talk about DanfeNER, named entity recognition in Nepali tweets. This is a joint work between myself, Noval Nirola, and my colleague Jivan Chapagai. This work has been published in the Florida Artificial Intelligence Research Society conference in 2023. So talking about the name here, Dafe, so it is coming from the national bird of Nepal. Is a beautiful bird, like you can see. Since we are processing tweets, talking about tweets, so DanfeNER sounds like a reasonable choice here. So, okay, let's go forward. Before we move to the detail, this work is supported by nepalishabdakosh.com. This is a resource for Nepali learners. It's a dictionary app basically. It has a lot of features. So if you are interested in learning Nepali, so this is the popular app that you can try. Okay, here's the outline of our talk today. We first give some motivation behind this work and then talk about some of the related works. Then we talk about corpus preparation, some of methodologies that we have followed, our results, and finally the conclusion. First, introduction. Social media like Twitter and Facebook are very important in our modern day society because they allow users to express and share opinions in any topic like sports, movies, politics, government, policies, and so on, or any events like earthquake and so on. Those have been very effective in sharing knowledge or opinions on any topic. Tweets in particular are very easy to obtain because Twitter allows users to post tweets using their mobile phones. And there are millions of Twitter users, which means we have millions of tweets coming on different topics. So we need some automated methods to process these tweets. And over here, we are proposing a machine learning method to process tweets in Nepali language for named entity extraction task. And especially on analyzing these tweets is critical because tweets are very rich in named entities like person name, location, organization, events, and dates, and so on. So we'll be focusing on processing tweets. And processing tweets is difficult compared to the formal news because tweets are short, they have a lot of informal language, typos, misspellings, acronyms, whatever, because there is a length limit in the tweets. So this is important yet challenging. So we'll be focusing on processing tweets in Nepali in this study. So if you are in natural language processing, you already know what is the task named entity recognition means. But just to recap, named entity recognition involves identifying and categorizing, entities in a text. Typically, we have a list of categories that we are interested in. And here is a fundamental task in natural language processing because it enables several downstream tasks such as question answering or pronoun resolution, or finding stats or training things, or so many potential applications of named entity recognitions. And therefore, it's a fundamental task. And in research-rich languages like English or French, there are training datasets, models are already available for people to try and process these tweets. But research-first language like Nepali is not studied much, and there is not much resource exists to process Nepali tweets. In fact, this is the first systematic study of named entity recognition for Nepali language in tweets. So also named entity recognition developed for formal languages such as news articles, they do not perform well for tweets because tweets are special, they are noisy, and there are a lot of issues compared to the formal languages. tweets, for example, has shorter length, it means it does not provide enough context to predict those named entities. So there are tremendous issues with tweets. So research have shown that the formal language NER models do not work well for tweets. And this is true for Nepali too. You will see later in our experiment sections that we validated this claim. You'll see a huge performance improvement by having tweet specific model over there. We'll be talking about more that later. How people tweet in Nepali, right? Let's study that part. There are several examples we have listed over here. So first of all, people type Nepali in different ways. In Devanagari script, like number 1, number 2, number 3, and number 4 over here. And the first one is, the first tweet over here is, पैसो जति यता रान अनि बैंकमा के को पैसा हुनु. So this is like a sarcastic tweet. It does not have any named entities. And if you are not Nepali speaker, you can see the translation on the parenthesis in the last part of each tweet there. So number 2 has one person called LinkedIn. Number 3 has location, Palpa, and Kaligandaki cover organization. You can see the Devanagari and English are mixed over there. And number 4 has event, organization, date, and so on. Number 5 and number 6 are interesting way of writing tweets, easier to write tweets in Romanized forms. And you can see there are mixed language over here as well. So in this study, we focus on extracting named entities from tweets that are written in Devanagari scripts. So the cases 5 and 6 over here would not be handled. That is, in fact, our future work that you will see later. So again, summary is we are processing only the tweets that are written in Devanagari script in this study. Our main contributions are following. First, we created the first benchmark dataset systems for processing tweets and extracting named entities from that. So we also developed end-to-end NER models to extract those entities from Nepali tweets. And finally, we provide a detailed error analysis, why the models are making mistakes, what could be the next steps, right? So a detailed error analysis has been done in this paper. Now we talk here about some related works. There has been some work in the literature that focus on extracting named entities from Nepali formal languages, basically the news articles. The first one probably, and in this one is Baum and Shahi in 2014. They created a named entity recognition system utilizing gadgetiers like person name, organization name, locations, etc. as features. It covers 3 types of entities: person, location, and organization. Similarly, Day, Paul, and Purkasta in 2014 developed a NER model using hidden markup language, hidden markup model with n-gram features. And similarly, recently in 2019, Singh, Padia, and Joshi created a NER model based on bi-LSTM and with word embeddings. It's a good work, but it does not have like annotation guidelines. Any human evaluations are not provided. And there is only few entities covered, like person, location, organization, and miscellaneous. The closest work to ours is actually our prior work, which we did in 2022. So in this work, we created a detailed annotation guideline and defined 5 different entities: person, location, organization, event, and date. And then we also trained several state-of-art transformer models, and that is the most closest work to ours. And just to recap, if you have not read that paper, this paper provides the largest dataset ever for extracting named entities from Nepali news. So please have a read of that if you have interest on that. Now let's talk about corpus preparation. We use a Python library called Tweepy to extract tweets. So in that process, we use the filter lang_any that you can see on the red font over here. What it does is it goes to the Twitter, grabs only the language, the tweets that are in Nepali language. It gives you the tweets in actually written in Devanagari script. So Twitter API has a rate limit, so we had to crawl data in multiple independent requests. As we know, tweets has a lot of noise like HTML tags, links, hashtags, emojis, mentions. So we remove those and clean those tweets. Also, we did not consider tweets that have smaller in length over here. Any tweets that are less than 5 tokens, we did not consider. So our final corpus size was 85,418 tweets. We randomized this. We removed all the duplicates. These are after the duplicates. And then that dataset is loaded in the Label Studio. So Label Studio is a tool where you can label different things. Over here, we utilize that for marking entities. So you can see over here that when we mark those entities, we mark in the character level. So tokenization has been an important and a difficult problem in Nepali text. So when we mark these records, one approach would have been like first tokenize and then mark, which we did not do it because tokenizer's output depends on which tokenizer we use, right? Rather, we annotated in the raw text. You can see the first one over here, Dewa. So we only mark that part as a person name rather than like Dewako. So it gives opportunity for us later on to experiment with different kind of models, character-based named entity recognition models, or later on we can tokenize this and then also create data sets for token labels. So a lot of flexibilities we can have with these character label annotations. So we consider, like I mentioned earlier, 5 different categories: person, location, organization, event, and the dates. We followed the annotations guidelines provided by our prior study. We got a very good interpreter agreement for marking these entities. So you can see that is set here with 0.75 based on Cohen-Kappa. Let's talk about the data sets. The DanfeNER data set, which is one of the contributions that we have made in this paper, we have 7,667 annotated tweets in Nepali language. In total, we got about 4,966 entities in total. So to create a train and test set, we split that data set into 70 and 30. So 70% records are in the train and 30% records are in the test data sets, so that any future work they can compare the model performance in the 30% of those records that we have set aside right here. And we also tokenize those annotated records so that character-based and both token-based things can be NER models can be trained. Here is the summary of the data sets. As I mentioned, there are 7,667 total tweets that we have annotated, and then 5,000 or so are in the train, and 2,000 or so are in the test. You can see the average tweet length is 17 tokens. And there are the numbers you can see on the right hand side over here: location, organization, person, and event and date. So each each of those entity counts in the train and test set. Interestingly, like the event category, it has very small number of records or entities compared to the other category. And this is the observation that we have made when we did a study of Nepali formal news articles. So there, we also observed very few type of events mentioned, and in the tweets too, we can see that similar behaviors. So this is actually a practical phenomenon where some categories are high in numbers versus some are less. So there's an imbalanced data sets we have to work with in the practical problems. So please note again that event category have few examples for the learners to rely on compared to the other categories. Now here I talk about experiments. We have trained different transformer models which have shown the state-of-art performances in named entity recognition tasks, including Nepali NER tasks. So we have different flavors of those. We have some monolingual transformer models and some have multilingual models. So the monolingual Nepali transformer models are trained from the scratch, whereas multilingual transformer models are trained with data sets containing languages that includes Nepali too. We have chosen 5 different transformer models that we have listed over here. NPVEC1, BIRD, Nepali BIRD, NIP BIRD, DB BIRD, and BIRD BBMU. The last one is multilingual. So the first one is the baseline model is our actually, that is one of our contributions in the previous years. This is the first BERT monolingual Nepali monolingual BERT model we have ever created, versus some others are the recent one emerged thereafter. The different transformer models and their properties are listed over here. Important thing to note is that all of these models are available in Hugging Face, and then model IDs are provided in this column I highlighted here. You can see different tokenizers, vocabulary size, training examples they used, and different parameter size as well. So talking about experiments, we evaluated models based on precision, recall, and F1 scores. These are the standard matrices we use for evaluating named entity recognition models. For each of these models, when we trained them for 10 epoch with learning rate of 0.001 and a batch size of 10. Our baseline system obtained F1 score of 0.63, and the best performing model obtained F1 score up to 0.80. So more detailed model comparison results are shown over here. In this table, you can see that we trained those models on the train set, DanfeNER train set, and evaluated them on the DanfeNER test set. And the highest performing model in the red had 0.8 F1 score, whereas the baseline model had 0.63. So the baseline model has less smaller F1 score compared to the others because it had a smaller size and only had one epoch trained. I mean, when the NPVEC1 BERT model was trained, it was only trained for one epoch. And also there were some assumptions made for pre-processing, which we did not respect in this experiment. So a lot of discussions on these results are also mentioned in our paper. So you can have a look at the paper to have more discussions on them. In these slides, we have listed the performance of our best performing model for each type of entities. So person, location, organization, event, and date. That you can see that precision, recall, F1 score, and support are provided for each of those entity type. The model is doing really good in multiple entity types. Person, F1 score 0.79, location 0.84, organization 0.79, and date 0.81. Interestingly, if you see over here, the performance for event is 0.37 F1 score for micro F1 score here. The low performance for event category is because if you recall, we have fewer number of examples for the machine learner to rely on or to learn from for the event category. We did not have many examples that we observe for the event type in our data set. So that is very similar to what we observed in formal Nepali NER problem or task as well. Here, we did some experiments to understand how the formal NER model trained on formal news articles perform on tweets. In the first experiments, what we did is we took the best performing model and trained using the news articles. Training data we prepared for the news articles, which is average NER train, and we tested that into the tweet test set, which is DanfeNER test set, and we got the F1 score of 0.69. We tested all in each of these cases. We tested always on the tweet test set, which is DanfeNER test, and here training on formal news article dataset and testing on tweet, we got 0.69 F1 score. In the second experiment, which we already did, we know that training on DanfeNER train and then testing on DanfeNER test, we got the F1 score of 0.8, which is 11% up compared to applying the NER model trained on news. So this is a huge boost we can get by having tweet-specific model. And this is a validation of our original claim that tweet-specific models are needed for extracting NER from Nepali tweets. Lastly, we combine both examples that are developed for formal news article as well as for tweet, which is DanfeNER train and average NER train, and then evaluated again on the DanfeNER test. We obtained the F1 score of 0.81, slight increase in the micro F1 score by 1%. So there is large improvement that we observed in the macro level, which we have not listed in this table, compared to the micro level. So we have discussed about that in our paper. We did the detailed error analysis of these models to see where they are failing, what kind of mistakes they are making. And here are some of the categories like code switching, foreign names, partial prediction, language ambiguity, tokenization, effect of Hindi language. Those are all different kind of errors the model is making due to those effects. And here code switching, the first one is तर म त्यो रेसमा छैन प्रचण्ड. So you can see that Prachanda last word is the person name, but our model could not find that one because that's written in English and we don't have good representation of those English words in our transformer models as well as in our training data set. So it failed to do that one. Similarly, foreign names, they have they are having problems understanding or identifying as named entities. Planning boys is a foreign name. But listed over here, we fail to get those names from our model because they don't have good representations in our embeddings as well as in training examples. So again, we have discussed detailed errors in our paper. Please read the paper to understand more about other categories here. So here is the conclusion. We did the first systematic study of named entity recognition for Nepali tweets. Part of that study, we constructed the DanfeNER datasets, the first benchmark datasets that are created for training and evaluating NER systems for Nepali tweets. We released these datasets in our GitHub page, which is listed over here. We also trained several end-to-end NER models based on transformers for processing or obtaining NER for Nepali tweets, and shown different comparisons with, we have different flavors for monolingual as well as multilingual models, how they compare. And also we validated that named entity recognition system trained on formal news article do not perform well for Nepali tweets, actually by a huge margin. Our future work includes discovering named entities in Romanized tweets as well as code switching tweets, which we have not handled but are very important area that we can do in future. Thank you for watching this video. If you have any questions or comments, feel free to reach out to our contact address over here. Also, you can provide feedback through our GitHub page that we listed before. Thank you again. Goodbye.